Good morning. Welcome to day 2 of Ignite. Hope you're having a good time. I'm Galen Hunt. I am the distinguished engineer at Microsoft. I've been there 21 years, which means either I've got real true grit or a complete lack of imagination. I am also I founded and I am the managing director of the Azure Sphere program at Microsoft, and I'm pleased to be able to be here today to talk to you about it. This is the first of a number of IoT-related sessions here at Ignite. I encourage you to participate in others of the sessions where you can learn about IoT Central and Windows IoT and a number of other things, particularly, and last one, talking more in depth about how Azure Sphere is part of Microsoft's overall IoT security strategy. Now, with Azure Sphere, we are taking Microsoft into a swim lane which we have never been in before. And that is the world of microcontrollers. A microcontroller is literally a single chip computer, if you're not familiar with them. It's a single chip that has processor, memory, storage, and I/O capabilities all on a single chip for a very low price point, typically on the order of just $1 or a small number of dollars, okay? And microcontrollers, or MCUs, are found in 9 billion new devices that get deployed every single year, okay? Into a population that's, we estimate, is somewhere between, a deployed population of somewhere between 50 and 100 billion devices globally that have MCUs in them. They go into everything from toys to home electronics, home appliances, and industrial equipment, okay? And these MCUs, they're so ubiquitous. Here's the way I'll describe it. If you want to know if something has an MCU in it, does it have electricity? Does it have a status light? And does it not have a color LCD? Because if it's got a color LCD, it's running a larger type device, like a cell phone class device or larger. But if it's anything smaller, doesn't have a color LCD, and it's got a status light, it has an MCU. Now, the reason this is important is because today, fewer than 1% of these MCUs are connected. They're all in standalone devices. If you walk into your kitchen, every single one of your appliances has an MCU, and I hope for your sake that none of them are connected yet. Okay? You walked in your in your child's toy closet, you'll find a lot of devices there, etc. 4 years ago, a colleague walked into my office with this schematic. And this was an MCU that was currently at that time was under development. It is now found in every single Xbox hand controller, okay? And what was revolutionary about this MCU, this chip, was the very first time I had seen of a chip that had not only a programmable MCU, but also a radio stack. It had Wi-Fi built into it. And it was, in fact, for 2015, it was the cutting-edge MCU. Now, I looked at this, and by the way, this had, in volume, a price point of about, say, $2.50, okay? And what I realized as I looked at this schematic was that this was the 5th generation of computing. The first was mainframes, then minis, then PCs, then phones. And this was, in fact, the 5th generation, particularly the 5th generation of internet-connected computing. And that these devices were going to be everywhere. For less than a cup of coffee at Starbucks, you could take any device on the planet and turn it into an internet-connected device. Now, think about that. Anything on the planet turned into an internet-connected device. I can guarantee you, however many devices you have on your network today, over the next decade, that number is going to skyrocket, and most of the devices that are connected to your network will be MCU-based. Okay? Now, why is that going to be? I'll give you a very simple example. All of you own a refrigerator. Okay? Now, you think about, how do you know that the compressor on your refrigerator has gone bad? Well, today you know because you go home and you've got melted ice cream and spoiled milk. But imagine a connected future. And that refrigerator instead is connected to the internet and has a little bit of ambient intelligence in it. And so instead, what happens is you get a message from the manufacturer of that refrigerator. And they say, hey, you may have noticed your fridge is making a funny noise. That's because your compressor is about to go bad. We have a technician that will be in your neighborhood this evening. Could that technician stop by and replace the compressor in your refrigerator? Technician, by the way, already has the right part on the truck. Could they replace it so that you don't experience any loss? Now, every single one of you wants to own that refrigerator and not the one with the spoiled milk and the melted ice cream. And your refrigerator manufacturer wants to sell you that refrigerator, okay? And that is what's going to cause a complete transformation of everything being connected, because once a device is connected, it profoundly changes the relationship between the device manufacturer and the consumer or the enterprise that bought that device. And for just a few dollars, they can change that relationship. And, yes, they can tell you that their compressor is going to go bad on their refrigerator. They can also tell you when the water filter needs to be replaced. In fact, instead of just turning on a light that says the water filter needs to be replaced, actually have the water filter appear in your mailbox, for example. Or be able to tell you, hey, give you a message, hey, the door's been open for a couple of hours. Are you sure that's what you want? Or do something like that. Okay. Now, with this opportunity of connectivity also comes significant risk. And I think you're probably leading to where this is, and that's because, well, what happens when you connect a device to the internet? Any connection between a device and the internet is inherently a two-way street. Packets can go out, but packets can come back in. And as a former colleague of mine, James Mickens, who's now a professor at Harvard, likes to say, the internet is a cauldron of evil. Okay? It's a lawless place. It's full of very many types of people, including many types of people who have no good intentions. Okay? Once you connect a device to the internet, all sorts of things happen. Now, you've all probably seen headlines about IoT security, about fridges being hacked to send spam, about baby monitors being compromised to either capture audio out of the home or to bring audio into a home. Okay? And that's when a device is compromised, it can impact your privacy, your data, your infrastructure, and even your physical security. Now, attacks can have larger social implications as well. And to describe that, I'd like to talk about the Mirai botnet attack. The Mirai botnet attack was in fall of 2016, October 2016. Hackers took over about somewhere between 50 and 100,000 devices, IoT devices. And it was relatively easy to do so. It turned out that every single one of those devices had the exact same administrator password, ROOT. Okay? In fact, the passwords on those devices were hard-coded into the flash. They took over these devices, they reprogrammed them, and they launched a denial-of-service attack against DYN. In case you don't know DYN, DYN is the major DNS provider, one of the major DNS providers in the United States. The effect of this distributed denial-of-service attack was to knock the entire East Coast off the internet for a day. There was no shopping, no chat. Frankly, I don't know what anybody did that day. Okay? Now, when one of these attacks happen, it matters. It becomes a societal impact because the device can be used as either a digital weapon or a physical weapon. Now, in this case, ironically, most of the devices were security cameras. So most privacy was at stake. But imagine had those devices been connected to some motor or blower or valve or something else. What could have happened with those devices? Now, you might say, well, there's some classes of devices, maybe security doesn't matter. A really low-end device like, say, a fish tank thermometer, security really doesn't matter. Well, I beg to differ. Can you imagine a fish tank thermometer compromising a casino? So this actually happened in Las Vegas. They had installed a network-connected fish tank thermometer into one of the fish tanks in the casino so that they could monitor the health of the fish. Hackers were able to compromise that device because it had very low security. Once they were on that device, they had a foothold and a permanent place inside that casino's enterprise network. They were able to use that foothold to explore the rest of the network. They found the high roller database, which is a valuable asset if you're a casino. They extracted the high roller database out through the fish thermometer and out onto the internet. Okay? The security of every single device on your network matters. Now, no device manufacturer sets out to build a thermometer that can be hacked or the ransomware refrigerator or the gas stove that can be used to blow up houses. No one does that to start out with. That's no one's intent. But how do you make a device actually secure? I'll put it this way. I've been at Microsoft 21 years. My entire career at Microsoft, I have spent dealing with security, internet security of one form or another. I often talk about it as the internet battle, the battle that comes to your device when you connect your device to the internet. And we've learned some very important things at Microsoft over the last 20 years. One of the things we've learned is that security is foundational. It must be built into every single device. And you have to build it in from the beginning. You cannot add security on after the fact. We have about a year ago, we published a paper called The 7 Properties of Highly Secure Devices. And what we found is for about 2 years now, I've been going out and talking to OEMs, device manufacturers, about the devices they build and having a conversation with them about security. And what I found is that often security comes down to almost a checkbox. Do we have security? Yes or no? Well, that's a very naive way of looking at security. Now, let me talk to you this way. Let's think about home security for a minute. Now, you might live in a home that has security cameras on every single entry. Maybe you've even got an armed guard or a security service. I grew up in a very small town in southern Utah. Security at our home meant we had a lock on our front door, and we never locked it even when we went on vacation because we never knew when the next door neighbors might want to come borrow some sugar. Okay? We had security, you have security, but these are very different kinds of security. So how do you talk about security? And to help people talk about device security, we've published the 7 Properties paper. Now, these properties, hardware root of trust, defense in depth, a small trusted computing base, dynamic compartments, certificate-based authentication, online failure reporting, and renewable security. If you're familiar with computer security, many of these terms you'll recognize. What we've done is try to define them as a set of properties and with a set of questions and explanations around those questions. And we use this word property very precisely. Okay? A property is something you can measure. You can take a device that someone's manufactured already or that, say, maybe your company's considering manufacturing, and you can ask these questions. Does it have a hardware root of trust? Does it have defense in depth? Does it have a small trusted computing base? Et cetera, et cetera. And depending on the answer to those, you know what kind of security you have. Okay? And what I'll argue is you want to have all 7 properties in every single device that you attach to your network. Now let me talk about these properties a little more. Some of the properties only require hardware. If it's been built in the hardware, you're good. An example of this is a hardware root of trust. Now let me explain what I mean by hardware root of trust. Imagine you're building a device, or you're going to buy a device, okay? But let's go back, you're building a device. There are some things fundamentally you want to know about that device before you give it to a customer and send it out in the wide world, and it connects to the internet and then connects back into your enterprise to provide data to your enterprise. One of the things you want to know is you want to know that it has a secured identity, a cryptographically protected identity that can't be stolen or compromised or forged. Another thing you want to know is that when it boots, when the hardware hands over the software and begins operation, you want to know that it's running the code that you put on that device, okay? That it's been signed by you. that code has not been compromised by anyone in your supply chain or anyone, or your consumer or anyone else. And this is a property we call secure boot. And I'll tell you why secure boot matters. The difference between a gas stove and an incendiary device, in other words, an explosive device, is a simple matter of programming. When do you turn on the gas? How long do you let it go before you turn on the flame? Okay. Running the right software matters. And finally, another property you want to know is when that device ultimately connects, after it's booted, it's been running for a while, and it connects to your enterprise, you want to know that it's still running the correct software, that the integrity of that device has not been compromised by some hacker in the interim. Those qualities of a hardware root of trust, those qualities have to be implemented actually in the hardware, in the silicon gates. Because if they're not, it doesn't matter how much software you add on top. You can have gigabytes of software, but if you don't have those qualities in the hardware root of trust, it's compromisable. Now, other properties in the 7 properties rely on hardware and software working together. And an example of that are dynamic compartments. Now, a compartment, what a compartment means is I break a software stack into separate compartments, isolation containers, so that a failure in one doesn't propagate to another. And examples of compartments in an operating system are processes. In a hypervisor, they're virtual machines. Okay? And you need the ability to have compartments and be able to reconfigure those compartments. And actually, this speaks to what is actually one of the oldest security techniques known to humans, compartmentalization. Such as multiple rings and keeps in a castle. Okay? So that when one becomes compromised, that you still have other areas that are protected so that you can re-establish and move the attackers out of your system. Okay? Now, finally, some of the properties depend on hardware, software, and a cloud working together. An example of this is renewable security through software update. So you think about it this way. I have a device and I ship a device out into the world. It's running the version 1 of the software that I put on that device. And we discover a new security vulnerability. Perhaps it's a bug in the code that we found. Perhaps it's a new kind of attack that no one had ever considered before. For example, the crack vulnerability in WPA2 protocol that was discovered a year ago. Okay? And so you put out version 2, you want to create version 2 of that software and get it out on those devices. So there's some things. Well, you need a cloud that's able to provide that update to all your devices. You need software on the device that knows how to consume that update and reliably and robustly deploy it onto the device. And also, you need hardware. And what you need hardware for is you need what we call rollback protection. Now, rollback protection addresses an important attack we call a rollback attack. What a rollback attack is, so let's say you've got all your devices out there, you've propagated version 2 that addresses this new security vulnerability, and it's deployed on all your devices. What do hackers do? Well, the first thing they will try is, can I convince the device to roll back to version 1 of the software? Because if I can convince the device to roll back to version 1, there's already a vulnerability I know of. I don't need to go find a new vulnerability. And so they'll do that. So you need a mechanism such as fuses that can be blown in the device so that it knows never again run version 1 of the software. It doesn't matter if it's been signed by the device manufacturer. You shouldn't load it. Okay? So we see how cloud, hardware, and software come together to provide the full renewable security property. Now, if you think about these 7 properties, as you start thinking about all the capabilities and qualities that are needed in those 7 properties, you might be thinking, well, that's going to be impossibly hard to put into a device that I'm building or a device that I want to purchase. And in fact, it is very, very challenging. We recognize that. There are almost, in the IoT space, there are virtually no devices in existence that have the full 7 properties. And what we've done at Microsoft, and what my team has done, is we have built a solution, an end-to-end solution, we call it Azure Sphere, for securing MCU devices. It has all of the components that a device manufacturer needs in order to create and distribute a device that has all 7 properties, that is secured with those 7 properties when it ships, and that throughout its lifetime, the device is updated and maintained by Microsoft, the security, so that it remains secure. Azure Sphere consists of 3 components. The first one are Azure Sphere certified MCUs. These are microcontrollers built by our silicon partners. Each of these microcontrollers includes a built-in Microsoft hardware root of trust. Now, let me explain that hardware root of trust and where it came from, or where we build it from. Microsoft has a number of hardware products. For example, one of them is the Xbox line of consoles. Those Xbox consoles, we've built 3 generations of Xbox consoles across 15 years. And in the Xbox space, we have very, very determined attackers because they want to compromise the privacy of consoles. They want to circumvent the software protections on the games, etc. And so we've built a very robust security system and a hardware root of trust in the Xbox. We took the learnings from those Xbox consoles and what we learned over that 15 years, and we built a hardware root of trust. We call it the Pluton Security Subsystem. And the Pluton Security Subsystem goes into every single Azure Sphere chip. Now, on top of that hardware root of trust and those chips, we run the Azure Sphere operating system. And the Azure Sphere OS combines the best of open source and Microsoft technology together to create a Microsoft-secured software platform for each of these devices. And then the third component of Azure Sphere is the Azure Sphere Security Service. The security service runs in Microsoft Cloud, and it reaches out and it connects to every single Azure Sphere device. Actually, correctly, the devices reach out and talk to it. Okay? And the Azure Sphere Security Service does 3 critical things. First, it brokers trust from device to device or device to cloud. It brokers trust through certificate-based authentication. One implication of that is that no Azure Sphere device has passwords. They use certificate-based authentication comparable to what we use in our best enterprise security systems. It also detects emerging security threats across the entire ecosystem of Azure Sphere-based devices so that we can automatically process online failure reports that come from the devices, detect emerging security threats, and address them. And we address them through the third capability of the Azure Sphere Security Service, which is renewable device security through software update. So we provide an update channel for the device, for the operating system, and also for the applications or firmware that's running on those devices. Now, let's drill in and talk about each of these components in a little bit more detail. So the MCUs provide a secure root of trust for connected intelligent devices. We start off with the standard base that you find in any MCU, which is you've got a real-time processor and some I/O capabilities. To that, we add 3 things that make a chip uniquely an Azure Sphere chip. The first one is connectivity. So some form of network connectivity. The very first Azure Sphere MCUs have Wi-Fi. We expect to see in later generations, we expect to see cellular, low-power radios, other wired Ethernet, etc. To that, we add Microsoft security that's built into the chip. I've already talked a little bit about the Pluton security subsystem that provides the hardware root of trust in the device. There's also internal Microsoft designed firewalls within the chip. Okay, now these are not network firewalls. They're actual firewalls between the compartments in the chip. So that, for example, if the network controller somehow becomes compromised, it's unable to get to the rest of the chip. On top of the security, the other thing we add is a new crossover processor capability. Now, traditionally, MCUs have run these very small real-time processors. They typically run around 1 to 200 megahertz, very small amount of RAM, etc. And we've added a more capable processor. what we've done is we've brought in the same kind of processor cores, the ARM Cortex-A cores that you find in cell phones, and shrunk them down small enough to fit into a single chip MCU. Now, we've slowed them down, we've done some other things in order to shrink them and reduce their power footprint. But these powerful Cortex-A cores, they do two important things in an Azure Sphere chip. One, they allow us to run a sophisticated operating system. So traditionally, an MCU on the real-time processor runs software that's called an RTOS, a real-time operating system. Now, that's really fancy terminology for DOS-era technology, okay? It's basically, an RTOS is just a library that you link together with your application, okay? And so what we've done with this Cortex-A is we can run a full high-level operating system, and the crossover capabilities also give additional processing power. So if you're going to take a device that was not formerly connected and now connect it, you're going to want to start enabling new experiences on that device. And we have enough processing power, typically 5 to 10 times the processing power that you'd see in a legacy MCU in one of these Azure Sphere chips. That gives us power to run, for example, ML locally on the device. As I mentioned, these chips will be built by our silicon partners. Now, the very first chip is being built by MediaTek. It's the I actually have one right here. It's the MT3620. It's already available in sample quantities and available in volume in the next couple of months. And we have additional partners that are helping us bring Azure Sphere chips to the market, okay? And we're very aggressive about trying to bring additional partners in. In fact, one of the things we're doing, the Pluton security subsystem, our IP block, we're licensing that royalty-free to the silicon manufacturers. We want them to build it into every single IoT device so that every single IoT device is secure. Now, on top of every Azure Sphere chip, we run the Azure Sphere operating system, okay? This is a multi-layered defense in-depth operating system. The first layer of the operating system is a security monitor. The security monitor guards the integrity of the chip and access to critical resources. If you're familiar with cloud computing, it's implemented on hardware with a hypervisor that protects the device. This is a very, very thin hypervisor that we have optimized for an MCU space. It runs in about 24K of code. Okay? Above the security monitor, we run a custom Linux kernel. We've taken the Linux kernel, we've optimized it for IoT and for security. Okay? Now you might ask, wait a minute, Microsoft is releasing an operating system using a Linux kernel. Why? Okay? The reason why is all of those silicon partners that I already described to you. In the PC space, we support 2 or 3, a very small number of silicon providers for our processors. In the MCU space, because there's a very rich set of verticals and a very diverse environment, we need to support a very large number of chips. Dozens of silicon manufacturers, many of them with dozens of chip lines. And the only way we could conceivably do that is by having an operating system kernel that is open sourced so that those silicon partners can easily create the compatibility with their chip as they need it. Above the kernel, we run a set of on-chip cloud services. These provide authentication, they provide the update services, and they secure the connectivity between the device and the cloud. And then finally, above that is the layer where the applications run. We have the application code runs in containers. We have 2 kinds of containers. We have POSIX containers where you run communication code, and then we have real-time containers where the safety critical code of the device runs. And those real-time containers run over on that Cortex-M real-time processor. The other containers run on the Cortex-A processor. That gives us a design that's very robust to attack and very capable of maintaining security and safety in these devices. Now, as I mentioned, each Azure Sphere chip connects to the Azure Sphere Security Service. And this Azure Sphere Security Service works with the hardware root of trust and the operating system to maintain the integrity of every Azure Sphere device. It protects the devices by providing certificate-based authentication. so there are no passwords on these devices. It detects emerging security threats through online failure reporting. It responds to threats by providing updates for the operating system and also a channel to provide updates for applications. And this allows the device manufacturer to not only we provide the capability to secure the entire chip for them, the entire device, but also for them, for example, to roll out new features to the device over time. And that infrastructure for update is built on the same infrastructure that we use for Windows Update. We literally have the capability to update billions and billions of devices per hour just with existing capabilities. Okay? Now, the other thing that we've done with Azure Sphere is we've brought the power of the Visual Studio programming environment to microcontrollers for the very first time. If you've ever programmed a microcontroller, I was talking with the AV guys here earlier today, and they'd actually, one of them would actually program an MCU. If you've ever programmed an MCU before, you'll know that the tools are very grounded in the 1970s. Okay? Very command line, very, very primitive tools. We've brought the full capabilities of Visual Studio to these devices. It's going to simplify development on the devices, streamlining debugging. We've got full interactive debugging, and we've brought full collaboration power to these devices as well, to the experience. And I'm going to I want to demo that for you, show you what that actually looks like, okay? All right, let's see. Okay, I'm going to pull up my camera. At the risk of making you all motion sick, I'm going to move the camera a little bit. Okay, what I have here, I have a flip dot display. Sorry, the time's off. Does anybody feel like it's 6:30 in the morning? I do. I came from the West Coast, okay? I've got a flip dot display, and I've connected that flip dot display to this MT36 development kit. So this has got an Azure Sphere chip. It's running the Azure Sphere operating system, and I've got this application that's running the clock. And I've got a couple of programmable buttons here on the board, and I've programmed this button so that when I press it, it scrolls a programmable message across the screen. Okay, just what the feature everybody wanted on their clock. We'll be selling these after the session if you want one. Okay. All right. Now, let's pop up. Okay, so I've pulled up the code, and it's very simple. I've got an example. We just have a control loop that polls to see if the button's been pressed. If the button's been pressed, it scrolls the message across, etc. Now, imagine I've got this device, okay? It's an MCU-based device, and I think, gosh, I would really like to connect this to the internet. I would like to know every time somebody pushes that button. So maybe I might want to sell that as an upsell feature, for example, or who knows. Or maybe I just want telemetry to just see how often are people pressing my button. How hard is that to do? Well, with Azure Sphere, it's very simple. Okay, so I'm going to break out of the debugger here. Okay, and all I do, I come in and I click on References. I say I want to add a connected service. I select that I want to connect it to Azure IoT Hub. I confirm my Azure IoT account. Okay. I choose the Azure IoT Hub that I want my data to go to. I confirm the type of device that I have, confirm that the connection settings are right, and the wizard then goes in and modifies the code within Visual Studio. It adds, you can see it's added an Azure IoT to hub.h and Azure IoT hub.c, so it's added the code for connecting to Azure IoT Hub. And then what I do is I add just a couple of lines to my code that then formats a message, and sends that message off to Azure IoT Hub. Okay? And I can hit F5 to build and deploy. And I now have a device. I've taken a device that was formerly a standalone MCU-based device, and I've turned it into a device that is securely connected to the cloud. It's cloud connected, it's secured, okay? And now I can build whatever wonderful new experience that I want to build. That's how easy it is with Azure Sphere to create connected devices, okay? Now, some of you here in this room work for companies that are going to build connected devices. Okay, and so I say, hey, you should go use Azure Sphere. We're going to make your life better. Okay, the rest of you are in companies and homes where you're going to see connected devices come into your environment, either in your home or in your work environment. As you look to those devices, you should make sure that they have all 7 properties, that they're highly secured. Now, the business model around Azure Sphere, it's 3 components: the chip, and the operating system, and the cloud, and the security service. And the way we sell is it's bundled. It comes in a bundle, 3 components, 1 low price, and no subscription fees. So that includes the chip. So if you're building Azure Sphere-based devices, you'll go to your distributor, your electronics distributor. You'll buy an Azure Sphere-based chip. With that chip will come the license to the operating system with ongoing on-device OS updates and a subscription to the Azure Sphere security service that is ongoing for as long as that device is in deployment as well. And we chose to use this model with no subscription fees because we didn't want people to make a choice on a month-to-month basis. Do I want security this month, or do I feel lucky? Okay. Azure Sphere is open. We're open to any MCU manufacturer licensing this Pluton security subsystem. As I mentioned, we license it royalty-free, so that it's not the licensing is not an obstacle to any MCU manufacturer adopting Azure, the Pluton security subsystem and adopting Azure Sphere. We're open to any innovation. Our OS kernel is open sourced. It's distributed under a GPL v2 license, so that device manufacturers, as they innovate, or not device manufacturers, but as the silicon manufacturers, as they innovate in the chips and create new capabilities, they can contribute those back to Microsoft into our master tree. We will vet that code for security. We will vet it for quality, and we'll help them make sure that they've reached our security and quality bars. And then we'll take the code. We're not going to check them for business model or do we think this is a good innovation or not. We are not going to be an obstacle to innovation. We're actually going to encourage it and help it move along as fast as possible. And finally, we are open to any cloud. Now, each Azure Sphere device will connect to Azure for the Azure Sphere security service. But once it's connected there and got its updates and verified its identity to broker trust, it can then talk to any cloud, public or private. You can connect it to AWS, you can connect it to Google, you can connect it to servers in the basement of your factory if you want. Okay? And that's because we realize we live in a diverse world, and we want every device to be secured. Now, we've been in private preview. As Satya announced yesterday, we are now in public preview. What that means specifically is, oh, I'm off by 1 slide. I've messed myself up. Okay, I'm going to flip over here. Okay, we're going to go do these slides out of order. Specifically, the Azure Sphere operating system is in public preview. The Azure Sphere security service is in public preview. And the Visual Studio tools for Azure Sphere are in public preview. And more importantly, because you need a chip to run it on, the Seed Studios, we're announcing general availability, public availability of the Azure Sphere development kits. So you can go online today, you can order an Azure Sphere development kit, you can download the tools for Visual Studio, and away you go. You can build your own flipped-out clock. You don't even have to buy one from me. Okay. Now, we have been talking and working with a number of early partners, OEMs, over the last 2 years. Some major names that you might recognize. And as we talk to them about Azure Sphere and they evaluate it, and as they've built prototypes, they talk to us about 3 key things that they see. And I use the terms security, productivity, and opportunity. They love that Azure Sphere gives them the confidence that they can produce highly secured devices and that those devices will remain highly secured after deployment and while they're in the field. They love that that's protecting their customers and protecting their brand. They love how easy Azure Sphere is to use, and particularly how easy it is with the Visual Studio environment to build and deploy their systems, and the productivity and the reduced time to market that the tooling gives them. And they love that Azure Sphere opens up an opportunity to transform their businesses and their products with confidence in the security of that platform. Now, call to action time. Each of you plays a vital role in the MCU ecosystem, whether you realize it or not. Some of you build devices that are built on MCUs or work at companies that do. If you build a device that is built on an MCU, make it secure. All 7 properties. Whether you use Azure Sphere or not, please commit. We will only ship highly secured devices. If you work in a company that deploys IoT devices, commit. We will only deploy highly secured devices. And each of you is a consumer. In your home, you're going to deploy devices. As you buy and deploy connected devices, commit. I will only buy and deploy devices that are highly secured. Because that's how we're going to secure the future and live in a much brighter world. Thank you. I encourage you to fill out the evaluation. Okay, we have 4 minutes. I'll take questions. All right, up here, yes.
So you mentioned that the security service provides updates. Is there any integration with advanced threat analytics?
With what analytics?
Advanced threat analytics?
We're working on that. So we're publishing out through the Microsoft Graph and going into there. Okay.
You mentioned devices is where you put the MCUs. What about gateways?
The MCU, they can be put into the gateways. We're expecting over time the more capable chips to come out as well.
And how much for the clock?
It's about $400. You all want one, right? Okay, next question. Yes, up here. Yeah, okay, so the question is there local storage on the chipset? Yes, so the chips, so these are MCUs, they have flash. Okay, now like the MT3620, the entire flash capability of that chip is 16 megabytes. Okay, there's really small chips, but there's enough place to store settings and to store things like that. Okay, and it is protected. So there's protection for each app container has protected storage. The operating system has its own protected storage. The question is it like an enclave SGX protection? You should think of it, it's more kind of like a virtual machine or container type protection, okay? So we don't have full confidentiality protection like we have in Azure Confidential Computing. That's an evolving feature. Yes, right here.
Talk about the funding model for the security service itself. You know, if these are sold and used on non-Azure clouds, how's it paid for?
Okay, so the funding model, how's it paid for the security service? Well, the answer is when you buy a chip and it comes with our license, there's a bit of royalty that comes to Microsoft to pay for the security service. And it pays for the security service subscription for the device for basically the lifetime of the device. Okay, so it's a one-time fee. It covers the device in perpetuity. And then, now, that only covers the security. So if your device wants data services, for example, you say you're hooking it to Azure IoT, well, that would be a separate subscription or whatever your cloud provider has. Okay, yes, up here. Wait a minute, Bluey, that's your third question. All right, you better be good, man.
I asked about the clocks.
Oh, okay.
Is there anything that needs to be done on the IoT gateways to support this? You know, it's got to connect to cloud and stuff.
So the question is about IoT gateways as a special support. So we just use standard IoT protocols. It's basically a TLS connection that goes up to the security service. So as long as you allow security TLS to be tunneled out of your network, you're just fine. Okay. Yes, over here. Yes. Okay, so the question is, if someone gets physical access to the device, is there something to prevent someone from being able to pull data off the chip? So the answer to that one is it depends on the chip itself. Okay. Now this chip, the very first Azure Sphere chips, the MT3620s, they have full protection of the chip itself. Let me say this. So our secrets for the keys that control the encryption on the device that are within our Pluton security subsystem, you have to acid wash the chip in order to get access to those keys, which means the only way you could get access at all is by destroying it. This chip is not technically considered a tamper-resistant chip. There are chips, and we expect there will be chips from some of our partners that will literally self-destruct if you try to open it up. The MT3620, if you wanted to open it up and steal the key for the chip, you would not get our key to our service, for example, with the chip. You could acid wash it and pull out your electron microscope and go read the keys. And by the way, you might all be thinking, oh, my electron microscope, where did I put that? I actually do have a security expert on my team who actually went and bought his own electron microscope off of eBay just so he could see how hard it was to pull the keys out, and it's pretty darn hard. Okay, so generally, we will not protect you against nation-state attackers from that protective. They have the scale and the scope to be able to extract a key from a device. But for practical implications, you know, a casual hacker, somebody with a couple $1,000s, these devices are protected. Okay. All right, one last question up here. The connection to Azure IoT Hub, yes, I think we support both kinds of certificates. I actually don't really know the answer to that question. I know we definitely support 509 certificates. What?
That means I win the clock.
You win the clock. No, this wasn't Stump the Chump. All right. Hey, thank you all for coming.